so today, we're still in 4.2. No, I think yesterday was 4.1. But we're still going to be graphing quadratic functions. We're going to be in the quadratic situation. Except today, we're going to graph from vertex form, where yesterday we graphed from standard form. And there are 3 different forms that we'll graph from. And actually, what I want to do first today is to go to your little foldable that we just put together. And let's look at this first side right here, the standard form. Right, the word standard. Let's kind of recapture what we learned yesterday. So we've got our standard form. Here's an example of your standard form right here. ax squared plus bx plus c. All standard forms have a, b's, and c's in them. When we did the standard, we graphed the standard form yesterday. We defined the line of symmetry and the vertex. What was the little formula that we used?
Negative b over 2a.
And it's x equal negative b over 2a, because what you get from that formula is an x.
So we wrote that with x in?
No, because our line of symmetry is actually going to be x equals whatever we got for this negative b over 2a. That's what our line of symmetry is going to be. And our vertex is a point, so this value would be negative b over 2a. But then how will I find the y value? Plug it in. So I'm just going to say plug in right here, and you'll have to kind of interpret that on your own, what that means to do. So that's a real quick summary of what we did yesterday. Actually, we did the first this middle piece right here. Yesterday, we discovered that if the vertex is at the bottom like this, what kind of vertex is that? Max or minimum? Minimum. And if it's facing down, this vertex will be a max. Like that. So let's open this first flap. I want you to have an example of each, graphing from each form. So open up your first flap, and let's graph this like we did yesterday. Let's graph from standard form. You've got a place where you can do your work at the top, and then we'll graph at the bottom in that first flap. So let's do the equation y equals x squared minus 2x minus 3. That is standard form, because we've got the x squared and the x in the number. Thank you very much. Then our vertex, we're going to do that whole negative over 2a thing, right? So in this case, negative of negative 2 would be 2. 2 times 1 equals 2. Looks like I'm getting a 1 there. So that 1 will be the x of my vertex. It will also be my, I'm going to do LOS, line of symmetry. That 1 will also tell me how to write my equation for my vertical line of symmetry, which will be x equal 1. Then let's decide how are we going to find the y of my vertex. Told me a while ago, and let me do that one.
Plug it in.
Plug it in. The original equation, plug the 1 in there, I get 1 minus 2 would be negative 1 minus 2, negative 4?
Yes.
Okay. My vertex is 1, negative 4. To find my x-intercepts, I'm going to set my y's equal to 0. I only have one line, but so I'm going to stick y, 0 for my y. Right?
Yeah.
Minus 3 plus 1. When I set both of those equal to 0, what are my two x-intercepts?
3 and negative 1.
X. 3 and negative 1. But you can't just say my x-intercepts are 3 and negative 1. You have to write them as points because your x-intercepts are points. And those points will have zeros for the last part. Then my y-intercept, what am I going to set as 0?
X's.
X. And if I put a 0 on x, here and here, both of those go away. And I'm left with
Negative.
beautiful. I'm going to pause a minute and let you guys grasp that. So today what we're going to do, before we move on to today to other forms, let's first talk about forms in general. Take you back to Algebra 1, pre-algebra days, okay? When we were just doing linear, do you remember what the different forms were that you used to write a linear equation? The most obvious one that most of you remember is y equals mx plus b. Do you remember what form we called that? Slope-intercept. And the reason we called it the slope-intercept form was because the slope and the y-intercept were staring at you in the face. You didn't have to do any manipulation of numbers or anything. It was just like, here's the slope, here's the intercept. And that's why they call it the slope-intercept. What other forms did you have with linear? Remember? Point slope. Point slope. What was that? This is the one that usually kids are least familiar with. With the point slope, let's say you're given that it goes through the point 2, 3, and you have a slope of negative 1. Remember this one? You would go y minus the y equals slope times x minus the x dot. That one. That was called the point slope form because, again, the slope is going, hello, here I am. And a point that it goes through is right here. 2 is your x, 3 is your, you took the opposite of both of those to your points. And then there was another one that all equations have a standard. And standard form always has a, b's, and c's in it. So for a linear, you would put your x's first, then your y's equal the number. That was standard form for a linear. What's that? No, we're not right though. No, I'm just connecting this to something you did in Algebra 1. So that was all linear. You've done all that. You should remember all that. So quadratic now, let's move up to our x squareds. We have the standard form, which is what we graphed in yesterday, and that was, ax squared. Maybe that didn't work. Ax squared plus bx plus c equals 0. Again, you have your a, b's, and c's. That's why it's called standard. Well, today we're going to go to the vertex form. We're going to see how to graph in the vertex form. What do you think will be staring at you in the vertex form? The vertex, yes. This is what it'll look like. It'll be a parentheses x minus h squared plus a. You may remember some h and k business from Algebra 1B. So let's go to the center now of your booklet, the center little flap on the front, the center one. And let's talk about the vertex form. Here's an example of the vertex form. They're pretty easy to recognize because you have x plus something or x minus something in parentheses squared. So it's pretty easy to see. So, I'm just going to tell you that the vertex, does anybody remember what the vertex is? If this is your equation, where you find the vertex? H and K. Your vertex is H, K. What you do is you take the opposite of what's in here. If it's a negative H, then your vertex is a positive H. If this is a plus H in the original equation, then it'd be a minus. So you might want to put a little arrow here to remind yourself it's the opposite of what's in the problem. And then K is exactly what it is out here. H and K. So on these problems today, when we're graphing from the vertex form, we don't have to do that whole negative yield to right thing. Because the vertex is staring at us. Beautiful. That's out of step. So let's put an example. Open up your middle flap. Open up your middle flap, and let's put an example in for this vertex form. Here's what it would look like. For your example, y equals parentheses x minus 2 squared plus 3. Still going to be looking for the same 4 things we were yesterday. They're just easier to see now sometimes in this form. Because the vertex is staring at me. What is the vertex? Positive 2, 3. That's the vertex, just like that. Didn't have to do a thing. So 2, 1, 2, 3. So 2, 3 is my vertex. Okay, now wait. Where did we get our line of symmetry? What did it share with the vertex? Did it share the x value or the y value? The x value. This right here, this is out 2 spaces. All of these numbers here are going to be out 2. So that means my line of symmetry is right here. And that would be x. Whoa, that was not going to show up. That would be x equals 2. This number, remember we, in the standard form, we got both of those with negative e over 2a. We don't need to do negative e over 2a, but there's still, those 2 items right there will always be the same number. Always, always. All right, for my x-intercept, I'm going to do the same thing. I'm going to set my 0, my y equal to 0. So I'm going to have 0 equals x minus 2 squared plus 3. Now this is going to be a little different. I mean, not different, but we're just going to have to use our math, the toolbox you have full of math tools since you've been in pre-algebra. How can I want to end up getting the x minus 2 squared alone on one side so I can put the square root on both sides. So let's get rid of the 3 first. How can I do that? Yep. So let's subtract the 3 on both sides. Now I can take the square root of both sides. So the x minus 2 equals plus or minus. Ooh, wait a minute. What is the square root of? How do I write? Ew, there's a negative under there. What does that mean? Imaginary. So this would be written as I radical 3. And then add a 2 to both sides. So x is really a positive 2 plus or minus I radical 3. Whoa, Miss McGinnis. How do you graph 2 plus or minus I radical 3? How do you put that on the x-axis? You don't. If you have an imaginary solution, that means you will have no x-intercepts because they're imaginary. How do you draw something that's imaginary? You can't put it on there. So when we go graph this in a minute, it better not have any x-intercepts. It has no x-intercepts. None. Nada. None. No x-intercepts. And then lastly, our y-intercept, we'll put a 0 in for x. And so that will be 0 minus 2 squared plus 3.
So it's 30.
2 squared is, 2 squared is 4 plus 3 is 7. Come up with 7. All right. Let's graph all that and see what
Wait, how did you get some?
I get 7. I took a 0. Took this, set my x equal to 0. So went to my original equation for the 0 right there. 0 minus 2 is negative 2. Negative 2 squared is 4. Plus 3 is 7. Yes?
Why is the vertex 2 and not negative 2?
It's always the opposite of your h, exactly your k. which is why on your charts a while ago I had you write opposite right here. H is the opposite of what it is in the problem. Okay? Yep. Let's graph these things. So my vertex is 2, 3, I did that. My line of symmetry, x equals 2, I did that. I have no x-intercepts, but the y-intercept is 0, 7. 0, 1, 2, 3, 4, 5, 6, 7. Well, if that is my line of symmetry, this point is 2 spaces from the line of symmetry, so I can do a corresponding point 2 over there. This we said is my vertex. Well, and sure enough, that baby will never, ever go through the x-axis. Now, if I said, what is the solution to this problem? The solution would be imaginary numbers. But if I say, what are the x-intercepts? Not any. Make sense?
Can wait.
I can wait. Do that. What? All right. Here we go. Let's try this one. I'm going to give you a couple of minutes to see how far you get on your own with this one. Again, notice it's in factor form. So vertex is staring at you. The line of symmetry should be very obvious. X-intercept, y-intercept. First thing I'll do, my vertex is staring at me. Where's my vertex? See what it's down there now. Negative 3, comma, negative 4. All right, negative 3, negative 1, 2, 3, 4. All right. My line of symmetry is going to share which of those values?
The x value.
The negative 3, but I can't just say line of symmetry is negative 3. Oh no, yes, it's got to be an equation of a vertical line. Equation of a vertical line is x equal this x negative 3. An x-intercept, I'm going to set a 0 for y. And here I need to do a little bit of math. So I'm going to say 0 for my y equals x plus 3, oops, that's something negative, squared minus 4. Okay, I want to get this squared thing by itself. So I take square root of both sides. So I assume most of you added 4 to both sides. But at this point, I really can't take the square root of both sides yet because of this negative hanging out here. So this is really, I could put a negative 1 right there, right? Because that's what that means, negative 1 times all that. So how about, let's divide both sides by negative 1 and just kind of negate that negative. So I'm going to divide both sides by negative 1 or multiply by negative 1, whichever you prefer. So now I have negative 4 equals just plain x plus 3 squared. Much better.
Do you also distribute?
No, because this is a square. That squared has to be done before you distribute.
Also,
So it would be mathematically wrong if you did that. Yeah. So x plus 3 falls out. And this is going to be plus or minus. What is the square root of negative 4?
2i.
2i.
Yes.
Oh, so that means x is going to be negative 3 plus or minus 2i. How many x-intercepts are there?
None.
None. No x-intercepts. Y-intercept, I'm going to set my x to 0 under my equation. So y equals negative 0 plus 3 squared minus 4. So that will be 9 minus 4. You come up with 5. 0, 5. Confirmation. Or I graph it.
What about the?
Confirm.
Yeah, the negative.
Oh, baby.
Oh, baby.
Okay, I lied. This is not going to be a 5 because I can't just quit that. So I'm going to square this first to get 9. So this is really negative 9 minus 4. Oh, so glad you caught that. For those of you at home, make sure you got that correction. Negative 13. So 0, negative 13. So So what the heck does this look like? 0, -13. When it comes off your graph, just kind of fake it and put something down here and say this is the 13. You don't need to be very make it perfect. Okay? I think there's one in your homework that's like -42. Well, don't take up a whole piece of graph paper getting that 42. Just put a dot and say that.
If it goes up a graph, it's just like these.
So, as I said, just fake it, put it out there and go for it. All right, so line of symmetry is going to go through, it'll be at -3, wait a minute, so this is my line of symmetry. Well, if -13 is here, so and I don't have any x-intercepts, this is what, 1, 2, 3 away? So 1, 2, 3 away. Sure enough, never going to go to the x-axis. Never, ever. Okay? All right. We need to do another one, or you okay. Let me ask you this. Let's say these weren't the directions, and instead, this problem said, what is the maximum or minimum value of this equation? Well, first of all, let's decide, is it going to be a minimum or a maximum?
There's a minimum.
Let's draw the graph, sketch the graph before you decide. So positive A. So it's going to go like this. So the vertex is going to be A.
Minimum.
It's the lowest point on the graph. So I'm going to have a minimum, and then minimum value is, okay, where did we find our minimum value last night on the homework? It was at our vertex, or was it the input or the output of our vertex? When I want the value. Output. You want to know what's the minimum thing that's going to come out of your machine. Well, what is the vertex of this guy? What is this point going to be? It's staring at you in the face.
3.
Okay,
1 and
good.
3.
Well, yeah, it's going to be the
-1.
the vertex itself is going to be -1, 3, opposite exact. But since I want the value, I want what's coming out. So the minimum value is going to be 3. So be careful if the instructions say to find the minimum or maximum value, you're only looking at the output. Okay? Don't forget that. All right. Don't need to do another one. Just out of curiosity, do anything. So, let's get out our books. Turn to page 249. So graph, we'll need all 4 pieces like we did before. But just label on the graph the vertex and the line.
So okay.